paper test, science, practice problem number one. Number one reads, Figure 1 shows that a seismograph located at a point 125 degrees around Earth from an Earth's focus would receive which types of seismic waves, if either, from the earthquake? It's a long question stem, kids. Make sure you put it in your own words and circle important information. We need to go up into Figure 1 and find 125 degrees. Then we need to look and find which type of waves are in that area. So simply go up. You see what I did? I reworded it into something that makes more sense. Simply go back up and take a look at Figure 1. Here is Figure 1. And in Figure 1, we are going to, let me scroll down a little bit. Figure 1, we notice that we are looking here at 125 degrees. It's not given to us. The information that they give you is 103 and 142. And we are given the new information of 125. So let's just write that in. Here is 125 degrees. Very common. They give you new information and you have to add it into the chart. Here's 125 degrees. And now you simply have to see what type of waves are we going to find in this area. In this area, you notice that we are in a shaded region here. The shaded region, there is a note about the shaded zone. Here's what it says. Neither P nor S waves received at the seismograph. You know the correct answer is going to say something similar to what you see right there. You go back to number 1. The correct answer falls in your lap. It says D. Neither P nor S in that area. Number 1, D is the correct answer. Test 70A, Science, Practice Problem number 2. Number 2 says, the results of which of the following experiments supports hypothesis 1? Here's what we're going to do. We're going to go find out what hypothesis 1 says, and then instead of looking in the chart at all the different columns, we're only going to check the ones that they give us as answer choices. This will save us some time. So let's go ahead and find out what hypothesis 1 says. When we scroll back up to the top and look at hypothesis 1, hypothesis 1 says mature cockleburs flower if and only if their leaves are exposed to a total of 10 or more hours of darkness. We need to find in the specific experiments a bar that has 10 or more hours of darkness each day. Remember, the difference between 1 and 2 is 2 says it needs to be continuous. In this particular hypothesis 1, they just says total of 10 hours. So we're going to have to go ahead, jump on in there and count them up. Let's go ahead and take a look at our experiments. And when we come on down here, we see the first answer choice is experiment 2. Now we're going to have to go back up here into Figure 1, and experiment 2 is here. Do we have more than 10 hours of darkness? The answer is yes. And does that produce a flower? Yes. So far, that answer choice works. Let's go ahead and check the rest of them. When you come on down to 2, you will look at answer choice G, which is 4, experiment 4, 6, and then 7. Let's go ahead and check 4, 6, and 7. Keep that on the top of our head so we don't have to keep scrolling up and down. When you come up to Figure 1, let's go ahead and take a look at 4. In 4, here are our experiments again. Scroll down to 4. Here's 4. Is there a total of 10 hours or more of darkness? Here is a spot of darkness, 6 hours, and here is a spot. 6 and 6 is 12. That is more than 10. That is true so far. When you have a total of 10 or more hours of darkness, you produce flowers. That's what it says up here in hypothesis 1. So now we have to look in experiment 4. We have a total of 12 hours, 6 and 6. But here it says in the flowering section that it does not flower. So that is incorrect. That can be crossed out right away. Let's go ahead and look at the next one. The next one is 6. In 6, we're looking for a total of 10 or more hours. We have 8 and 8, which is 16. That is more than 10, so that works so far. But you see here, it says it does not flower. We're looking for more than 10 hours with flowering. 6 is out. Let's look at 7. 7 is 5, 10, 15, 20. So far, so good. That's more than 10 hours of total darkness. But you see that when you have more than a total of 10 hours of darkness, hypothesis 1 believes that you will have flowers, and here it says no flowering. The only answer choice that's going to say more than 10 hours of total darkness and producing flowers is experiment 2, 20 hours here, and flowering. That means experiment 2 is the only one, and our answer will be answer choice F for number 2. Test 70A, Science, Practice Problem number 3. Number 3, be careful. This is kind of a weird rewording here, so we have to put it in our own words here and make it as easy as possible. Here's what it says. All 3 hypotheses would have predicted that flowering would occur in which of the following experiments? Now, if you put this in your own words, we have answer choice A, B, C, and D, and all 3 of them would say which one of these 4 produces flowers. It's as easy as that. 3, 4, 5, and 6. Remember, all 3 would predict flowering would occur. So that means when you look at figure 1, the end result in figure 1, the end result over here would be flowering. So let's go ahead and look at the answer choices. 3, 4, 5, and 6. 3, 4, 5, and 6 right here. And now we simply have to look and see which one flowers. Flowering. 4, no. 5, no. And 6, no. So the only answer that's going to work here is experiment 3, because in experiment 3, all of the hypotheses predict this is going to produce a flower. How do you know that? Because here is the experiment, the light-dark cycle, and the flowering here in figure 1. The correct answer, therefore, is going to be answer choice A, experiment 3. Test 70A, Science, Practice Problem number 4. Number 4 states, do the results of experiment 14 support hypothesis 3? First thing we need to do is find out what hypothesis 3 says. Let's go back up into the experiment, and you'll see that hypothesis 3 states, here are the hypotheses, mature cocklebur plants flower if and only if their stems are exposed to a total of 9 hours of darkness or more. 9 hours of darkness or more, and it's the stems, not the leaves. Let's go ahead and jump back down and take a look at experiment 14. Here is experiment 14 in figure 2. And let's go ahead and see, first of all, is there more than 9 hours of total darkness? Yes, there is. There's 20. According to hypothesis 3, if there's 9 hours or more, then there should be flowering. Here, there is no flowering, so the answer is going to be no, because the plant did not flower. Answer choice J. It's simply a matter of combining results. Look at the criteria for experiment hypothesis 3, and then go back into experiment 14 and see if there was more than 9 hours, and if there was, there has to be flowers. In this case, there's not. Answer choice 4, J. Test 70A, science, practice problem number 5. Number 5 says, based on hypothesis 1, which of the following light-dark cycles would not result in flowering? First thing we need to do is scroll on up and take a look at hypothesis number 1 and see what they say. Remember, in hypothesis 1, it said, mature cocklebur plants flower if and only if their leaves are exposed to a total of 10 hours or more of darkness. So we're looking for something that does not work. We're looking for something that is not a total of 10 hours when we go into problem number 5. Let's go ahead and take a look here. Answer choice A says 2 hours of light, 10 hours of darkness, 2 hours of light, and 10 hours of darkness. Remember, hypothesis 1 says you need a total of 10 hours of darkness. We're looking for the answer that shows not 10 hours of darkness, and therefore answer choice A can be crossed out because there is a total of 10 hours or more. A is out. Look at B. B, there is 6 hours of light and 18 hours of darkness. Remember, hypothesis 1 says we need 10 hours or more of total darkness. Here, 18 is more than 10. That will work. We're once again looking for the answer choice that's not. Answer choice C, 3 hours of light, 9 hours of darkness, 3 hours of light, 9 hours of darkness. Remember, it says in hypothesis 1, a total of 10 hours or more. It doesn't necessarily say continuous. That is experiment 2 or hypothesis 2. So if you look here in C, we have 9 darkness and 9 darkness. 9 and 9 is 18. 18 is more than 10. So that will work. Once again, we're looking for the answer that will not work. Answer choice D says 18 hours of light, 6 hours of darkness. 6 hours is not enough. We're looking for 10. So D is the correct answer. A word of warning. Whenever you read a question and it says the word not, least, or except, go ahead and circle that in the question stem here, because theoretically you're looking for the answer that will not work. 3 of the 4 answer choices will be true statements. We're looking for the one that is not true. So make sure that you remind yourself you're looking for the not answer by simply circling this. 5, the correct answer is D as in dog. Test 70A, science, practice problem number 6. Number 6 states, both hypothesis 2 and 3 would have predicted that flowering would occur in which of all the following experiments? First thing you want to do here is make sure you understand what you're looking for. We need to go back and look and see hypothesis 2 and 3 and see what the requirements are. Then what we need to do is see if one of those experiments down here would produce flowering. That means when we go up to the chart here in figure 1 and 2, we can simply, here's figure 2, we can simply look up here, find the experiment on the left, and then find flowering on the right. Would flower, so that means the answer for our experiments is going to have to say yes. If you see a no in that column, that answer choice can be eliminated right away. So let's go ahead and take a look at it further. We want to go ahead and look at experiment 1, 10, 12, and 14. If you go back up here, experiment 1, without even looking at 2 and 3, you see it does not flower. So that is right away an answer choice that we can cross out. When you come back over here and you look at the next answer choice, which is experiment 10, then 12, and 14, we're going to be in figure 2. Let's look at 10. Here's experiment 10. Yes, it does flower. Let's keep it. 12, no flowering. 12 is out. And 14, no. So far, the only answer choice that we found here in this particular section here is experiment 10 that does have flowering. Go back up, look at experiment 1. Once again, no flowering. You know right away that the correct answer choice for this particular problem is the only one that will do what they're asking you to do, is would flower. That means the answer for under the flowering column has to be yes. G is the correct answer on that one. The second thing we could do is, if that doesn't satisfy your interest, you can go back up to hypothesis 2 and 3. In hypothesis 2 says we need 10 or more continuous hours of darkness. And here it says we need 9 hours of darkness. So we need at least 9 hours of darkness to have both of those work. If you look over here, answer choice, the first one says experiment 1. Well, you see that there's only a total of 4 hours, so you know that that is going to be wrong. We go over here and we took a look at experiment 10. 9 hours of darkness. Yes, there's at least 9 hours of darkness for hypothesis 3, and hypothesis 2 says at least 10 hours of continuous. Both of those requirements are satisfied, and it does flower. All 3 components are fulfilled. We look at experiment 12. Do we have 10 hours of continuous darkness? Yes, we do. Do we have 9 hours of darkness? Yes, we do. But it does not flower, so 12 would be crossed out. Look at 14. 14, once again, it's the same thing. We've got at least 9 hours of darkness, and we have at least 10 hours of total continuous darkness, but it does not flower. Right away, we derive the correct answer of experiment 10, which is answer choice G, just by simply looking at would it flower, and then going up to the graphs and looking in this column, would it flower? Yes, has to be the answer. If the requirements are met, then it would flower, so it would have to be yes. 10 is the correct answer. The only one that will get us to the right answer choice here is G. Test 70A, science, practice problem number 7. Number 7 says, which of the three hypotheses, if any, is weakened by the results of experiment 9? First thing we want to do is let's quickly go up to experiment 9 and see what we see in experiment 9. When we scroll on up to experiment 9, we see that experiment 9 is in figure 1 on page 38. Here is figure 1 on page 38. Here is experiment 9, and here's what we see. We see 10 hours of light, 2 hours of darkness, 10 more hours of continuous light, and 2 hours of darkness. A total of 4 hours of darkness, and when we have 4 hours of total darkness, there is no flowering. Now, we're trying to weaken experiment 1, 2, and 3, or hypothesis 1, 2, and 3, so let's go ahead and see. When we see there's only a total of 4 hours of darkness, does this weaken hypothesis 1? Let's go ahead and see what they say. Mature cocklebur plants flower if and only if the leaves are exposed to a total of 10 hours or more of darkness. Does this weaken hypothesis 1? Remember, what we saw in experiment 9 was a total of 4 hours. That does not meet the criteria of 10 hours or more. So it does not weaken hypothesis 1. When we look at hypothesis 2, it says mature cocklebur plants flower if and only if their leaves are exposed to a block of 10 hours of continuous darkness. Remember, what we saw in experiment 9 is 2 and 2 with a total of 4 hours of darkness. That would not weaken hypothesis 2. And if we go up to hypothesis 3, it says mature cocklebur plants flower if and only if their stems are exposed to a total of 9 hours or more of darkness. Remember, what we saw here in experiment 9, we did not see anything close to 9 hours. We saw 2 and 2, a total of 4 hours of darkness, so that would not weaken experiment 3 as well. So when we come back down to problem number 7, do the results of experiment 9 weaken any one of these hypotheses? The answer is no. They don't weaken any of them. 7 is D. Test 70A, science, practice problem number 8. Number 8 reads, which of the following graphs best represents the wetting from the results in table 1? First thing we need to do is we need to scroll on up, find table 1, and then look for the column that says wetting. Then we're going to take the numbers from the column that says wetting and go ahead and throw them into one of these charts here. For example, if you look at the charts down over here below, it says talus sloped, farm terrace, lightly grazed, heavily grazed. Let's scroll on up and find table 1, column wetting. When we go to table 1, we find table 1 here. We look at the x-axis on the top here. We find the column that says wetting here. We take these numbers here and plug them into the bar graph. For example, here in the talus slope, we produce 12.7, so right around 13. The farmed produces 19, lightly grazed 21, and heavily grazed 9. So let's take the first two off the top of our heads, right around 13 and 9. Let's scroll back down and take a look at some answer choices. If you look at answer choice F, F has the correct answer because here is the bar graph, 10 and 15, halfway between is about 13. That's what you saw from the bar graph here. And then this one here, the farm terrace, remember, was 19. This one was 21. And this one was about 10. That's what we got from table number 1. We plugged it in here, and we'll check that out. Here's 13. Here is just under 20. Here's a little over 20, 1921, and here is right around 10. This is the correct answer. If you scroll down and look at some of the other charts, you'll see that answer choice G is wrong, because remember, we were looking for the talus sloped at 13, but in G the talus sloped is down here at 20. So right away, just by looking at the first column under the talus slope, you'll see that that one's incorrect. If you go ahead and look at answer choice H, H says talus sloped is 21, so that one is wrong as well. And then over here in answer choice J, J says the talus slope was 9. Remember, all you need to do is simply look at table 1, the column that says wetting, and you will quickly see these numbers just need to be translated into the bar graph. Remember, the bar graph, the numbers that will be correlated here, even though this is upside down and slightly confusing, this is the shaded region, which means we go from 0 down to here where the unshaded region is not counted. F for problem number 8. Test 70A, Science Practice Problem number 9. Number 9 states, is the statement, the average soil erosion rate was the greatest for talus slopes, supported by the results in the study? First thing we need to do, just like we did in problem 8, is go take a look at table 1, look at the top column that talks about soil erosion rates, then find talus slopes and see if the numbers are the largest. Let's go ahead, scroll on back up to table number 1, and we are going to find the column that talks about erosion rates. Here we are in table 1. Then what we want to do is in the x-axis here, we want to find the soil erosion rate, which is this second to the last column here. Then what we want to do is look and find talus. Here is talus, and see, are the numbers in this column corresponding to this being the largest? Here we have 22 for talus. That is indeed larger than farmed. That is indeed larger than lightly grazed. But you see that this, in the last column here, the terrace heavily grazed is actually the largest. So the answer to this question would be no, it's not supported. The reason it's not supported is the erosion rate for terraced, heavily grazed is larger. So we'll go on down to the answers down here and take a look for an answer that says that. First of all, we can go ahead and cross out the answer choices that say yes. If you look at answer choice A and answer choice B, it says that this is supported when it's actually not, because we saw that talus was not the greatest. So now let's go ahead and see why. No, the average soil erosion rate for talus was greater than the farmed, true, and for the lightly grazed, true, but less than the heavily grazed, true again. That will lead us to the correct answer of C. Go back and take a look at that one more time. If you look at the column that we were in, we found erosion rates up here in table 1. And you see that that's the correct answer. Here's the erosion rate. Talus is larger than farmed. It's larger than lightly grazed, but it is not larger than heavily grazed. So C is the correct answer. Let's jump on down and take a look at the last answer choice here. Answer choice D, and see why D is incorrect. If you look at D, D says no, which is correct so far, but here's what it says. The average soil erosion rate for talus was greater than farmed, correct, but less for lightly grazed. That is not correct, because you saw that simply by looking at table 1 in the second to the last column. 9, the correct answer therefore will be answer choice C. Test 70A, Science Practice Problem number 10. Number 10 states, the most likely reason that the terraces located in the same mountainous region were selected for study was to ensure that the terraces would be similar as possible with respect to which of the following variables. First thing you need to do here, kids, is this. Put this in your own words. They're asking you, why were these mountains selected? We're trying to find some similar variables or control variable. Which one of these is a control variable that they're not testing? Number 1. So right away, you can go back to table number 1 and look at the columns. If there's a column that says soil erosion rate, runoff, climate, terrace category, and the numbers are different, then that would tell you right away that this is not a control variable, that this is not similar, and that would therefore be an answer choice we can go ahead and cross out. If you preview your answers here, you'll see that F says erosion rate, G runoff rate, climate for H, and J says terrace category. So when we come back up here, we will take a look at table 1 and look at the x-axis here in the columns. First thing here is this. We have time to runoff, runoff rate, soil concentration, soil erosion rate, wetting. Then we have the type of surface, which ranges from talus all the way down to terrace, and 3 different subcategories of terrace. So which one really is the one that would be the control variable? They wanted to keep everything similar. Let's go back down to the answer choices and take a look. First of all, F. Is F a control variable? Well, soil erosion rate we saw in this column here, and here is the soil erosion rate. Is that similar? 22 to 7? No, that is definitely not similar, and therefore answer choice F can be crossed out right away. If you look at G, G says runoff rate. Runoff rate was one of the things we saw up here. Here is the runoff rate. Is that similar? 36 to 16? Nope, that can be crossed out as well. It's different, and it is also an experimental variable. It can be crossed out. Answer choice H says climate, and J says terrace category. Go ahead and look in the columns here. First of all, do we see anything that says climate in the x-axis? Nope. Do we see anything that says X climate in the y-axis? No. That would be the correct answer, because if you find the same mountain, it's got the same weather conditions. Answer choice H is going to be the correct answer. Let's go ahead and see why J is incorrect. J says the terrace category. If you scroll up here to the y-axis in table 1, terrace category, here is the type of surface, and here is the terrace category. This is a slope, and this is a terrace, farmed, lightly grazed, and heavily grazed. If you look over here, you see that the slope is 300 and the farmed is 600. That is a very big difference. It is not similar, and therefore it is an experimental variable they're switching around, and heavily grazed is different than farmed by quite a bit. Therefore, that answer choice can be crossed out right away. Remember, if you're looking for something similar and you see these things in the chart, you can go ahead and look at the numbers and see if they're similar. Also, it would hint that if it's in the category with one of the tables, you can assume that they're probably testing to see if it actually is something that changes. Take your answers, plug them back into table number 110 is going to be answer choice H. Test 70A, Science Practice Problem number 11. 11 says, according to the results of the study for the farm terraces, the average time elapsed between the beginning of the simulated rainfall and the beginning of the runoff in minutes was closest to which of the following? First thing you need to do here is go up and take a look at table number 1. We're looking for the farmed terraces, and then we need to find a column that says the average time elapsed between the beginning of the rainfall and the beginning of the runoff. So we come up here, let's go ahead and find farm terraces in table 1. And when we look here in table 1, we find in the y-axis here farm terraces, right? And now we need to find the beginning of the simulation of the rainfall to the runoff time. Here is the time to runoff. Here is the runoff rate, soil concentration, soil erosion rate, and wetting. Geez, I don't like that. I look back over here and I feel a little bit confused. So let's read that one more time. It says the average time elapsed between the beginning of the simulated rainfall and the beginning of the runoff. And I feel like that might be a definition. So what we can do now is go back to the mini introductory paragraph up here, and you can finger scan for what they talk about, the beginning of this or the beginning of that. When we come over here, here's what it says. The time to runoff. Here's the definition of time to runoff. And it says the time elapsed between the beginning of the rainfall and the beginning of the runoff. That's exactly what we're looking for. So time to runoff is the column that we need to find. If you're unsure, go back. They'll probably give you a definition up in the mini intro paragraph. Time to runoff is the x-axis we're looking for, and farmed is the y-axis. Now it's simply a matter of dragging your finger over and finding the number under this column here, time to runoff. We see that we have 629 seconds. Let's go look at our answer choice and see which one of them is 629. Well, if you look over here, here's 629, but they want to know what this is in minutes. How many seconds are in 1 minute? 60 seconds are in a minute, so 60 times 10 would give you roughly 600. So you know that it's going to be 10 minutes and 29 seconds. You look at your answer, that would say something close to that. B is the only answer that will give you something close to that. Remember, if they give you something in here that you're not sure of, go back and look for a definition in the mini intro paragraph. The bottom line comes down to this. You really need to just go and find where it talks about farm terraces, and then scroll your finger over and find a number that's underneath one of these columns. If you're not sure which column, go back up and read. Correct answer for practice problem number 11 is going to be answer choice B, 10 minutes. Test 70A, Science Practice Problem number 12. Number 12 states, do the results of the study support the statement? On average, for all 4 surfaces, all of the simulated rainfall that was applied ran off. First thing we need to do is this. We need to keep in mind that they're looking for all of the rainfall. Did all of the rainfall run off? We need to find out how much rainfall they put on, and then compare the chart and see if it all came off. So what we can do is we can go back to the mini introductory paragraph and we can finger scan for the word rainfall to find the right area. When we come back up here to the beginning, passage number 2, you just get going and find rainfall. Does this give us numbers where they put the rain on? No. Keep going, rainfall, rainfall, rainfall. Finally, we come over here and we find that they applied the rainfall here and it looks like they applied 75 millimeters per hour for 45 minutes. That's what they applied. So what we need to do is look at now the column that says runoff rate and see if these numbers are at or around 75. Here the talus slope says 36, 18, 16, 35. Remember, they applied 75 millimeters per hour for 45 minutes, and that is going to be, these numbers are definitely less than that, so the answer would be no. It did not all run off. That means that some of the rainfall actually seeped in, which would be common sense to tell us that when you soak your grass, some of the water will actually seep into the grass. So first things first, we can go ahead and cross out answer choices that say yes, because all of the rainfall did not run off. So that means yeses can be crossed out. Let's take a look at answer choice H and J. H says no. We're on track so far, but here's what it says. Because all four types of surfaces, the runoff rate was greater than 75. Well, that's wrong, because it was greater than 75. You go back into table 1, look at your column here for runoff, and you see, are these numbers greater than 75? No. First of all, it's getting the wires mixed up. That is wrong, because it's not greater. And common sense tells you that since the amount applied was 75, how is more water going to run off than they actually applied? So that is going to be wrong because of the word greater. Let's look at J. J says no, because all four of the types of surfaces run off was less than 75 millimeters per hour. That is correct. If you look at the runoff column here, you look at the different types of surface, these numbers are all less than 75. Therefore, the correct answer for problem number 12 is going to be answer choice J. Test 70A, Science, Practice Problem, number 13. Number 13 states, which of the following statements best explains why the soil erosion rate for heavily grazed terraces differs from the soil erosion rate for lightly grazed terraces? Then they say heavily grazed terraces did what? First thing we need to do is let's go into table 1 and see what's going on here and get our feet wet. So when we go back up to table 1, we're going to find in the y-axis here, we're going to find lightly versus heavily grazed terraces. Then we're going to go ahead, scroll over the x-axis till we find erosion rates. Here is erosion rate column here. We compare light to heavy grazing. It looks like when there is lightly grazed terraces, the erosion rate is 7.1, which is considerably less than heavily grazed terraces at 26.1. So common knowledge would tell us this. Grazing is like a cow eating grass. They send cattle to eat the plants on the land. So when you have a lot of cattle eating the grass off the land, there will be more erosion. So that tells us that the more plants you have on the land, the less erosion. See what I did? I just kind of put this information in my own words. That would make sense because the more plants you have on the land, the more roots for the grass, the more the water is going to seep in and get on the grass in itself, so it's the less likely it's going to be able to run off. So if you were to go ahead and draw some arrows, your arrows would say this: the more plants you have, the less erosion. Now we can take that information, translate that information back into the question and find the answer. If you look at problem number 13, they say this: heavily grazed terraces had less vegetation because there's going to be more grazing. So you know that more is going to be out. We can easily go ahead and cross out A and B because you know that when there's heavily grazing, there's going to be less vegetation. We're left with C and D. Let's look at C. There's less vegetation covering than the lightly grazed terraces. When there's less vegetation, they were less resistant to erosion. Now put this in your own words. Less resistant to erosion, that really means more erosion. Less resistance means more erosion. Was there more erosion? Yes, there was, because remember, it was 7 compared to 26. That would give you the correct answer. D says less vegetation than the lightly grazed terraces and therefore more resistant to erosion. If this was correct, the numbers would be flip-flopped from table number 1. Remember, it looks like here when we found lightly versus heavily grazed terraces that the erosion weight was greater in heavily grazed terraces. The only answer when you translate this and flip it around, the answer that comes up best is indeed answer choice C. Heavily grazed terraces, there is less vegetation because the animals eat the vegetation than in lightly grazed terraces. And when there's less vegetation, you are less likely, less resistant to erode, which really means it's going to have a higher erosion rate. 13, remember, put this in your own words. You're asked to kind of reword the information in your own way. C for 13. Test 70A, Science, Practice Problem number 14. Number 14 reads, between t equals 0 seconds and t equals 30 seconds in study 1, the voltage across the capacitor did what? First thing we need to do is we need to go into, take a look and see figure 2. Figure 2 says time versus volts. And how do you know it's volts across the capacitor? Because you could simply come up here and look and find out. If you don't know or aren't sure what this means, it says it up here. It says voltage across the capacitor. That's exactly what they ask us about in this question. Voltage across the capacitor. So we basically looked at the y-axis and defined it above in the mini intro paragraph. Now, it's a relationship question. What happens as you increase from 0 to 30? Here is 0, and here is 30 in the x-axis. And it looks like as we increase from 0 to 30 here, it looks like the voltage across the capacitor goes from 0 to 1 to 2 to 3 to 4. So it looks like if we were to put arrows in here, that is a positive relationship. As you increase the time, the volts also increase. It does not go down, and it does not, it just kind of levels off. So it looks like the relationship is direct or the relationship is positive. When you come down over here, you find an answer choice that says increasing only. That will lead you to answer choice F. Remember, if they ask you about some information here, you might need to define what this means by looking at the X or Y axis and then going back up into the mini paragraph and looking to see how it's defined. 14 is F. Test 70A, Science, Practice Problem number 15. Number 15 says, based on Table 2, starting at t equals 0 seconds, it most likely took how long for the charge on the capacitor to equal 200 PCs in Study 2. First thing we need to do is locate Table 2. Then we need to find out the time when you're at 200. Let's scroll on up to Table 2. And you'll notice that when we go into Table 2 is here. We basically need to go to the column here, QPC, and find 200. So if you scroll down, you see that there is no 200, but there is a 240 and a 150. So it looks like halfway in between is about 90. So we can go ahead and say that our 200 is going to fall right in between 5 and 10 seconds, because 200 would squeeze right in between there. So we're looking for an answer choice that's between 5 and 10 seconds. Off the top of my head, I would probably say 8. Scroll on down, look for an answer choice that's between 5 and 10, or somewhere around 8. And when we look at our answer choices, there is no 8, but there is exactly what we're looking for, what you see there, between 5 and 10 seconds. It's that easy, kids. 15, B. Test 70A, Science, Practice Problem number 16. Number 16 states, suppose that in Study 1, the voltage of the battery had been 10 volts instead of 4 volts. Based on Figure 2, once the capacitor is fully charged, the volts across the capacitor would have been. First thing we need to do here is put this in your own language. We need to go to Figure 2. Once you go to Figure 2, find out what did it take to get a full charge when we were set at the original amount. A full charge when we were set at the original amount of 4 volts produced what? We come over here, we find Figure 2. Here's Figure 2. And when we put 4 volts in here, what gives us a full charge? Look here, a full charge is exactly what you see, 4 volts. So if we were given a 10 volt, that would tell you simply that full charge on a 10 volt would be exactly that, as being 10 volts. You see that? Full volt battery fully charged will give you 4 volts. A 10 volt battery up here would give you the same thing, 10 volts. Let's go look for an answer choice that says the same thing as what we just previewed. 16 is answer choice G. Don't get tripped up with the tricky language or wording. It's basically saying a 10 volt battery is fully charged at what? 10 volt battery fully charged at 10 volts. G for 16. Test 70A, Science, Practice Problem number 17. Number 17 says, which of the following statements best explains the value of Q at t equals 0 seconds in Study 1? Then it gives us some information. At t equals 0 seconds, what happens? First of all, I look at this and I say, I don't remember what Q was. It's kind of a boring passage. Even though I've had this kind of material before, the physics stuff here is a little boring. I don't know what Q is. I don't remember. So what we need to do is we need to define what Q is from the mini introductory paragraph. Remember, we're in study 1. They have to give us a definition of Q in study 1. So let's go back to the top and simply finger scan for Q. Where does it give you a definition of Q? Remember, finger scanning, start at the top, say Q as you go from left to right, down, and backwards. Q, 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 Q. We're not really reading. We're just simply trying to locate the area that talks about Q. What is the definition of Q? We keep going, and finally we find Q down over here in the bottom underneath figure 2. Q, 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 Q. Here's Q, and here's what it says. It says, using the data from figure 2, the computer calculated the charge on the capacitor, Q. Q is the charge on the capacitor. All right, now we've defined what Q is. Q is the charge on the capacitor. Well, we want to know at t equals 0 what happens. So let's continue going back into study 1 and find table 1 right here. Here is t, and here is t equals 0. So what happens? T equals 0, what happens? The Q is 0. And what is Q? Q is the charge on the capacitor. So when the time is 0, the charge on the capacitor must also be 0. Look for an answer choice that says the same thing as what we just previewed. The answer at t equals 0 is the capacitor was uncharged. Remember, always use the information they give you. Go into the study you're looking for, define an unsolved value of what they're talking. What is Q? Define, find out what that is, and then plug that information into t equals 0. Now, another way to look at this is if t equals 0, you could have went up here in the study 1, found t equals 0, and translated this into your own words. T equals 0, then Q must equal 0. What's another word? Even if you didn't know what Q was, what's another word for Q equaling 0? The voltage? No, V is voltage, so that's not Q. A is the correct answer here. Practice problem number 17. Remember, always define your values here, Q, in the mini intro. Test 70A, Science Practice Problem number 18. Number 18 states, based on Table 1 and Figure 2, as the capacitor was being discharged between t equals 0 seconds and t equals 30 seconds, in Study 2, the voltage across the capacitor did what? First of all, they're asking you about the number one common thing in ACT science. It's about relationships. As the capacitor is decreased, what is going on? Looks like this is decreasing, but it looks like the time is increasing. Right away, just by reading that information there, you know that it says this. The time is increasing, put your arrow in there, and it's telling you in the question that the discharge on the capacitor, that means the energy off the capacitor is going down. Discharging is down. You already know that the relationship is going to be a negative relationship. So, if this is increasing, then this must be decreasing. G. Number one. Number two, let's say that you didn't pick that up. We know that when we come over here, we need to go for sure into Study 2, because that's what it's asking us about. Now wait a second here. Let's take a look and see where Table 1 and Figure 2 come from. If you find Table 1 and Figure 2, you see that Table 1 is up here, which is part of Study 1. Wait, what? And Figure 2 is also part of Study 1. So, well, wait a second. They're not asking us about Study 1. They're asking us about Study 2. So if you look over here and you start getting confused here, you could easily get confused. Here is 0 to 30, and here is, remember this? This is volts across the capacitor, which we saw from one other question. This means this is increasing the volts across the capacitor. But the question is not asking us about that. The question is asking us about decreasing. So that means that this is a positive relationship. As you increase the volts, the time will increase. Well, what happens when we decrease this? We're going to lose charge across the capacitor. So that's the second way that you could get the answer correct. The third way is to do this. Come back in here and say, I need to go to Study 2 and see what the relationship is between time and voltage across the capacitor as it's being discharged. Go to Study 2. Go up to Study 2, look at the graph. Here is Study 2. We've got Figure 3, which is a diagram. It's not very helpful. But Figure 4 shows us that as we go from 0 to 30, right here, it looks like it's a negative relationship. It's being discharged or emptied. We're going from 40 down to 0. So that would tell us this is a negative relationship. The only answer that's going to work on that one is going to be decreasing. Simply look at Figure 4. 3 ways to get the correct answer here in 18. It is a confusing question, but look, follow the 3 different ways. Doesn't matter to me as long as you get the right answer. 18 is G. It's based upon relationships. Make sure that you understand what they're asking you here. Put it in your own words. Test 70A, Science, Practice Problem number 19. Number 19 states, which of the following statements best explains the value of I at t equals 100 seconds in Figure 4? At the 100 second mark, what is going on? First thing we need to do is let's go back up to Figure 4 and look for a new value, and that new value of I, what happens at 100 seconds? Let's go back to Figure 4. In Figure 4 is right here. And let's go ahead and look at the XY axis. X is t seconds. Y is I. And what would the value of our I be at t 100? Here is t here. And it looks like our I value at 100 seconds here is going to be 0. So now we want to try and figure out what this I stuff means. Go back up, finger scan up here for I. I is the current flowing through the resistor. And here is what's going on. We're discharging the capacitor. So you can assume that up here at 40, this is going to be a full charge. And then when you get down to 0, that is going to be empty. That just makes common sense. So what happens at the 100 mark? since we are discharging the capacitor at the 100-second mark, I is 0, so therefore the capacitor being just discharged down to 0 is going to be 0 or completely discharged. Look for an answer choice that says the same thing. Answer choice D, number 19, says the capacitor was fully discharged or empty because the value is 0. It's that easy, kids. Number 19, make sure that you understand and reword this into your own language. When I first did this problem, I misread the question. I actually got the wrong answer. Then when I went to spot check my answers, what, Thomas? No way. And I looked at the answers. It's actually a very easy question, but it sounds hard. Remember, put it in your own words. Go back to the place they tell you. Look for definitions of I and look at what happens at T. You see that capacitor is 0. D for problem 19. Test 70A, Science, Practice Problem number 20. Number 20 states, according to Figure 1 and Table 1, which of the following graphs best shows how MP melting point varies with the atomic number of group 2A? First thing you want to do here is you want to go combine the results from Table 1, Figure 1. Let's go ahead and look for group 2A. And in Figure 1, we find group 2A at the top here of this column, and we see that we're looking for these particular atomic numbers, 4, 12, 20, and 38. We're associating them with beryllium, magnesium, calcium, and strontium. When we come over here, let's go ahead and find them in Table 1, and you see it looks like we just have this column here, beryllium, magnesium, and calcium. So we took that information, put it over here. Now, here's the first column that we're interested in, melting point. We see that with Be, beryllium, which is atomic number of 4, that it is 1280. Then, as we increase to magnesium, remember up here we went Be4, now to Mg12. That's increasing, and Ca20 is also increasing. It looks like we go Be1280. Now we drop down to 650, and then for the last one, calcium, we go back up to 850. Let's go ahead and look over at our answer choices. Here is the melting point. So the first thing we want to do is plug in one of your answer choices and find 1280 Be with an atomic number of 4. Look at F. F looks like it's about 1280, between 1000 and 1500. Scroll over here, about 1300. Go down here, looks like we're right around 4 or 5. So far, so good. Now, if you look here, magnesium is 12 with 650. So here is the next dot. We're right above 500. That's right in the range of 650. And here, if we come down over here, 10 to 15, that's right in the right area of the atomic number, which is 12. Then if you look over here, remember the next one was calcium at 20. We go over here. Calcium, it looks like from this column is 850 at 20. And here is the dot they give us. Go across. It's under 1,000, between 1,000 and 500. That's good for 850. And if you look here on this axis, that's 20. F is the correct answer. You just have to combine results from both Figure 1 and Table 1. If you look at the rest of the answer choices, you see they're just flat out wrong when you do the same exact process. F for 20. Test 70A, Science, Practice Problem number 21. Number 21 says, barium Ba, like Sr, is a group 2A element. The atomic number for Ba is 56. Based on Figure 1 and Table 1, which of the following is most plausible set of values for the atomic radius of Sr and Ba? First things first, let's scroll on up and take a look at the information in Figure 1. We're given the information in Figure 1 that it is a 2A element. In 2A, we notice that we have Be, or beryllium, with an atomic number of 4. Then we go down, we see Mg, magnesium, is 12. Calcium, Ca, is 20. Then here is our Sr, strontium, 38. We're given that information. Then below this, they said that we now have a new element, and that new element is going to be Ba. And it looks like Ba is 56. Let's take this information now, what we just did here, and we are going to plug it in and look for that in Table 1. When you look in Table 1, here is Be, beryllium. Let's go ahead and switch over to the pen. I can start writing some stuff in here. So we said the beryllium here, the atomic number is 4. Magnesium, Mg, was 12. Calcium was 20. Then they gave us some new information. Let's go ahead and just write it in here, down here. Sr, they gave us the new information, was 38. That was from the chart because that was just below, right up here, remember? And then the new information they gave us was Ba is still a 2A element, and we said that the atomic number on this one was 56. Alright. The next thing we need to do is we need to find out the atomic radius. Here is the column we need to go to. Here is where we will be working. It looks like as we increase the atomic number from 4 to 12 to 20, it looks like we go from 111 to 160 to 197. If we use our arrows, we see that as we increase the atomic number, the atomic radius will also increase. It's a plus-plus relationship, or direct. So when we go down to Sr, there is no Sr in the column here. We know that our Sr value here, which I'm going to put in this imaginary box here, our Sr value is going to have to be above 197. That is because the atomic number 38 is larger than calcium, and we saw that this, as we increase here, we also will have to increase here. Now, the last thing is Ba, barium has a larger atomic number, so we can assume that the number on the bottom here for Ba will have to be larger than the number that we predicted for Sr. Take that information and look at your answer choices. Our answer choices for practice problem number 21, answer choice A, we know that Sr has to be larger than calcium, and calcium was 197. So we know that anything that's less than 197 can be crossed out just by looking at this Sr. A and B are out, 50 and 70. Now, we're left with Sr of 220 or 235. Now, remember, we said that Sr atomic number was 38, and then we were given the new information about barium being 56, so Ba is going to have a larger atomic radius because we saw the arrows, and we predicted that our Sr value would be larger than 197. So if you look over here, the last two choices we have are Sr at 220 and Ba at 235, or Sr 235, but this is lower. Well, you already know that Ba has a larger atomic number, and therefore it will have a larger atomic radius because it's larger than the SR. So the value here is going to only give us C, 220, and then it will get larger for BA. Combining results is a very common thing on ACT. You're given information from two different areas. You need to take information from one area and plug it into another area. 21 is C. Test 70A, Science, Practice Problem number 22. Number 22 reads, based on Table 1, at 1,000 degrees Celsius and 1 atm, aluminum exists at what state and sodium exists at what state? First things first, we need to go to Table 1, find aluminum and sodium, and keep in mind that we are now at a temperature of 1,000. We go up here to Table 1. Here is Table 1. Let's go ahead and find aluminum. We scroll down here in the element content. We find aluminum, and we find that aluminum has a melting point of 660 degrees Celsius, and we're given the new value of 1,000, so you know that this is definitely melted from a solid into a liquid. Let's go ahead and check the boiling point. And the boiling point for aluminum is 2,470. So it has not boiled and turned into steam or a gas yet. So this is melting at 660. We're given a new degrees. Tells us that this is liquid at 1,000 degrees because it melts at 660. Now, do the same thing. We come over here in the elements column. We find sodium. We find that sodium melts at 98 degrees and boils at 890. We're given a new value of 1,000. So that means that at 890 this is boiling. And boiling a liquid, changing it into a steam, would be going from a liquid into a gas. So since the boiling point here is less than 1,000 degrees, sodium would be steam or a gas, and aluminum would be a liquid. Let's go down, take a look at answer choices that say the same thing. When you come over here in 21, you will see, 22, you will see that aluminum will be a liquid and sodium will be a gas. That will lead you to the correct answer choice of H for practice problem number 22. Test 70A, Science, Practice Problem number 23. Number 23 states, according to Figure 1 and Table 1 for Period 3 elements groups 1A through 4A and their ions listed for those elements, as the atomic number increases, the ionic radius does what? First thing we need to do is combine results from both Figure 1 and Table 1. Let's go on up, and we're going to find Period 3. So we'll scroll on up to the top here. Here is Figure 1, and let's go ahead and look at the period. Here's the period, and we're looking for Period 3. Here it is here. So we see sodium Na, which is 11 for the atomic number. Then we go magnesium is 12, aluminum 13, silicon 14, and so forth on the way down. Looks like we're increasing the atomic number. what happens to the atomic radius? First of all, let's go ahead and find sodium and find out what is going on with the atomic radius. Sodium is here. We have the lowest atomic number, and the atomic radius here is 186. Now, let's see what happens as we go to the next element up here. Magnesium has a larger atomic number by 1, 11 to 12. Now, let's go ahead and find magnesium. And you see magnesium has an atomic radius of 160. It looks like we go down. We come over here, we look at the next element. The next element over here, 13, is aluminum. Let's find aluminum, look at the atomic radius. Here is aluminum, and here is the atomic radius, 143. It looks like we're continually going down. Let's go ahead and take a look at the next one. The next group up here from period 3 is silicon at 4. We're increasing still. Find silicon here. And we continually go down, 117, as we increase the atomic number. Great place for your arrows. You see that the atomic radius goes down. Let's go back to the answer choices and see if anything falls in our lap right away. Come down over here. You see, as we go across here, the atomic radius and the atomic number, as you increase the atomic number, the ionic radius is going to decrease. What you saw here from combining the results and just simply plugging them in, finding out. Correct answer on this one, relationships question, is C for 23. Using your arrows would be helpful here. If you saw what I did here, I went ahead, found out what those were from figure 1. I wrote them down, and then right next to it I just listed off. So I had everything, instead of going back searching in and out, I just had them written down on the side of my paper here. So I knew that the arrows were going opposite directions. C is the correct answer for 23. Test 70A Science Practice Problem number 24. Number 24 reads, which of the following statements comparing the ionic radius to the atomic radius for a given element is best supported by table 1? Compare to the size of an atom. The size of the ion is what? Size of the atom compared to the ion. Go back up to table 1. In table 1 here, we can simply take a look at the answers over here. We have the atomic radius and the ionic radius here. And let's just simply go here. We have 152, and that's large, and the ionic radius is small. We have large atomic radius here for sodium, and ionic radius is small. Large for potassium, for the ionic radius is 133. Small, large, small. Keep going. Large, small, large, small, large, small, large, small, large, small, large, small, up, small, large. Uh-oh. See what I did here, kids? I kept going. I didn't stop after the first 4 or 5. You guys probably started getting bored. Thomas, what are you doing? 1, 2, 3, 4, 5, 6, 7. You gotta check the whole thing. Here, something happened weird. We're small going to large here. So what do? We check here. Here is negative ion, but if you look at all the other ones up here, plus, 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 plus. When it's a positive ion, the radius of the atom will be larger than the ionic radius when it's positive. When it's negative, what we see is it flip-flops. Let's go ahead and take a look at oxygen. Small here, large here, negative. Let's continue down and look at the last few down over here. These are all negative. Are these small, large, small, large, small, large? So the answer has something to do with this. Let's go down and take a look at the answer choices here for 24. Let's read the question again. Which of the following statements comparing ionic radius to the atomic radius for the given elements supported in Table 1? Compared to the size of an atom, the size of an ion is smaller regardless. No, we saw that when it switches from positive to negative, it changes, it flip-flops. G, larger regardless. No, you see that this regardless can be crossed out right away because you see we flip-flop large to small for positive and small to large for negative. H says smaller, the atom is smaller if the ion is negative, but if larger, the ion is positive. Well, ion is not positive. Ion we saw is negative, so that doesn't make any sense here. Let's look at this one. That's confusing. Look at J. Compared to the size of the atom, the size of the ion is larger if the ion is negative, but smaller if the ion is positive. There we go. That's the correct answer. And look at it one more time here with me real quick. You see that when we're up here in Table 1, you see that we started off the atomic radius here versus the ionic radius, and we go from large to small, large number to small number, large to small, large to small. And in the meantime, when we do that, it's large to small for every single one of these here. Large atomic radius or atom, and the ion will be smaller. That's when these numbers are positive. We switch when these numbers become negative. These numbers here will be small for the atomic radius of an atom, and the ion radius will be larger in the negative ones. That's restated for the correct answer in problem number 24, which is answer choice J. Test 70A, Science, Practice Problem number 25. Number 25 reads, based on the genotypes for gene R and gene P, the parents of each of the phenotypes here, RRPP, RRPP, crosses most likely had which comb type? First thing you want to do is you want to take these genotypes and plug them into Table 1 over here and see where they come from. Capital R, lower p, lower p. You see that when we trace it and look in the genotypes here in this column, the only place that we're going to find that is right here, and that is under the comb type of rose. Then we take the second one and do the same thing. Lower RR, capital P, lower p. We go over here into Table 1 in the genotype, find that, and you see that that lower RR, capital P, lower p, comes from the comb type of a P. So we know that the correct answer is going to have to be the parents came from rose and from P. Cross out answer choices that you know are wrong. Answer choice A says both came from rose. Well, we know that's wrong because one had to come from the P. B says both parents came from the walnut. If you look in the walnut, walnut doesn't have either one of these genotypes, so that can be crossed out. C says one parent came from walnut and the other from the pea. The pea part is true, but neither one of these came from the walnut. Remember, the correct answer has to say something about rose and pea. D gives us that choice. One parent came from the rose coombe and the other parent came from the pea coombe. D is the correct answer for 25. Test 70A, Science, Practice Problem, number 26. Number 26 states, what was the genotype for gene R and gene P of the walnut-combed offspring with a genotype of these two things crossed? The first thing you want to realize is this, that when you're coming in here and you're dealing with genetics, if you have this coming from the mother and this genotype coming from the father, when you mix them together, they're going to mix and match. So right away when you look over here, you look in the R section and you see we have one capital R and a lowercase r and two lowercase r's over here. There's a total of 4 chromosomes, and that means that there's only one capital R. So when you come over here, there's no possible way that you can get 2 capital R's, because there is, between this combination, there is no 2 R's. F can be crossed out right away. If that's true, then G is wrong as well, because here you see 2 more capital R's. You cannot get RR when you only have 1 capital R between the 4 chromosomes. Now let's go ahead, take that a little further and look at answer choice H. We're going to look at the P gene here. In the P gene here, you see here is 2 lowercase p's and a capital P and a lowercase p. Out of the 4 chromosomes, we only have 1 dominant or 1 large p. So there's no possible way we can get 2 large p's. There just isn't 2 large p's in there. There's only 1 large p here. The dominant gene, there's only 1. So that means that that's going to be crossed out. If you look over here, it says capital R, lower r. Here we have a capital R and a lower r, and we have 2 lower r's. If you combine these together in the right way, you can get a lower r and a capital R, just like you have in answer choice J. Then we have a capital P and a lowercase p here, which we see we have 1 capital P here and multiple options over here for the lowercase. That is a possible genotype as well. J is the correct answer. Remember, if you only have 1 P, there's no possible way you can just magically have 2 capital dominant P's come about when there's only 1 to start with. They don't come out of air. They're combining together with each other. 26 is J. Test 70A, Science, Practice Problem, number 28. Number 28 states, based on Table 1, a chicken that is homogeneous recessive for both gene R and gene P will have which type of coombe? If you look over here, here is Table 1. And now what we need to do is we need to figure out what the heck homogeneous recessive is. If you look up here in the mini introductory paragraph, it tells you right here, it says lowercase letters indicate recessive alleles. Homogeneous means all of the same. So, homogeneous recessive, if you look over here, where are all of the lowercase letters? That will tell you that that is homogeneous recessive. Here is capitals. I see capitals, 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 capitals. Here's 2 recessive, but here's 2 capitals. 2 recessive, 1 capital, getting closer. And here is 2 lowercase r's and 2 lowercase p's, which means they're all lowercase or homogeneous. And what kind of coomb does that produce? Single. That will lead you to the correct answer of answer choice J. Notice I'm not worrying so much about terminology. This actually looks like the word comb, but I'm producing it as coomb. It doesn't matter because I'm getting the right answer, everyone. So don't worry about the lingo or the terminology. Some of you kids might say homogeneous. I say homogeneous, homogeneous. You know, doesn't matter. Just get the right answer and get out of there. 28 is J. Test 70A Science Practice Problem number 29. Number 29 reads, suppose 2 single-combed chickens were crossed. Based on Table 1, the percent of the offspring with walnut combs would most likely be closest to which of the following? First thing we want to do here is we want to go to Table 1. Here is Table 1. Second thing that we want to do here is we want to go ahead and look for 2 single-combed. So here we have 2 single combs. So here is the genotype. That means the mother had this genotype and the father had the exact same genotype. How many walnut combs could be produced when you take RR PP lowercase and multiply it by the same thing? RR lowercase, PP lowercase. Go into walnut and see if you can get any combinations from everything that is homogeneously recessive. You see here, we can't get that genotype because that is all dominant genes, and we don't have that here from the mother or here from the father. Over here, 2 capital R's dominant, here is 2 dominant, and over here is exactly the same thing from the mother and the father. We can't get capital R's or dominant genes because all we have is recessive. That's out. Here is 2 capital P's or dominant. We don't have that. We just have recessive. That's out. And over here, we still have a capital R, capital P, which are both dominant genes. And once again, over here, you have the mother and the father have the exact same genotype. Lowercase rr, lowercase pp. You cannot get any of the walnuts because genotype for the walnut needs dominant genes, and that's not what you see here when you mix 2 single-combed chickens together. So the answer for this one is going to be it's not possible. It's not possible translates to 0% for problem 29. Test 70A, science practice problem number 30. Number 30 reads, in which of the following trials was the distance between car X and car Y increasing? Let's go ahead. We're going to have to look around a little bit here. Here is figure 1. Let's get a bird's eye view of what's happening. Here is car X and here is car Y. We want this distance between the two to increase. Now, we're going to take that information. We are going to go and look at table 1. We're dealing with car X and Y. So if you look over here under the first symbol, this is dealing with car X and car Z. That's not information we need. We need XY. Here is ZX. We don't need it. YZ. We don't need it. ZY. We don't need it. And here, finally, in the second to the last one, we see that the symbol V sub XY gives you the velocity of car X when measured from car Y. We're looking for a positive value because the velocity of car X that's positive when measured from car Y would tell you that car X is pulling away from or increasing the distance away from car Y. So now we know that we need to look in the category of V sub XY. We'll take information from V sub XY from table 1, and now we are going to combine it with the results from table 2 and find V sub XY column here and look for a positive number. If you look over here, here are the trials on the y-axis over here, 1 through 8. We're looking for a number that's positive. Negative, 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 positive. This is the only one that has a positive value for VXY. That means that car X is pulling away from car Y, which would increase the distance. This is the only trial. Then you look over and see what trial that is. It is trial 5. Very common question on ACT. They're asking you to combine results from 2 different areas to figure out the problem. Problem 30, the only answer that will give you the right answer here is answer choice G. If you look at trial 1, 6, and 8, those are all negative numbers in the V sub XY column. 1 negative, 6 is 0, 7 is negative 1. The only answer that's going to work is a positive value, which is trial 5. Problem 30, correct answer once again is G. Test 70A, science practice problem number 31. Number 31 states, in trial 8, based on the measurements by the passenger in car X, how far did car Y travel in 5 seconds? First thing we know is this. We're going to need to find out about car X and car Y. We're going to come over here, take a look at trial 5, table 1, XY. So you will see that here is V sub XY, the velocity of car X when measured from car Y. So this is what we're looking for. Now we need to go to trial 8 and find V sub XY. Scroll down to table 2 here. Go into trial 8 here. Come across and find VXY. VXY is here in trial 8, and it looks like it is going a negative 2 meters per second. Come over here, and we want to know what happens in 5 seconds. It's losing 2 meters per second, negative 2 meters per second against car X times 10 will give you a total of 10 meters. It's 10 meters behind car X after 5 seconds. Correct? Don't get worried about the negative symbols in there. You realize that whether you're catching up or slowing down, it's going to be positive or negative. It's basically 10 meters. Answer choice A for 31. Test 70A, Science, Practice Problem number 32. Number 32 reads, suppose that an additional trial was conducted with the following results for these particular columns. In the additional trial, VYX is most likely closest to which of the following? Here's what we need to do. We need to go down here to table number 2. We need to take the new value for VXZ, which is -3, and see which trials are closest, and then base the new trial and guesstimate off of the old information. Let's go ahead and plug in our information. Here's what we have. It's VXZ. VXZ is here in column 1. The value they give us is -3. We see that in trial 1 we have a -3, so we are on track here. Trial 1, 2, 3, and 4 have that same value. Continue on down the line. VZX is column 2. VZX, the value they give us from up here is, again, -3. We see that trial 1, 2, 3, and 4 have a -3. We keep moving. We go to the next one. The next one is VYZ at -1. VYZ is column 3. They give us the new value, -1. The closest value we have is trial 1 with a -2. If you notice that if we put our -1 above trial 1, we call it trial 1A, it would go -1, -2, -3, -4, -5. So it is the closest so far to trial 1. Let's keep moving. We come over here and they give us new information. It's VZY. Let's find it. VZY is here. The new information they give us is -1. Trial 1 is the closest again with a -2. If we take this new information, -1, put it just above here in trial 1A, it would go -1, -2, -3, -4, -5. So far, trial 1 is very close to what we are looking for. Now, here's what we need to predict. It says in this additional experiment, we're looking to predict VYX. VYX is here, and we see that the closest trial that we have was trial 1, so our value for VYX in trial 1 is -5. And if you remember from these two values over here, they gave us a -1, a -1. So if we simply went 1 less than what we see here, like we've seen the pattern for the rest of the trials, you would be able to predict that the value for 1A, the trial we're trying to predict, would be 1 less than this, which would be -4. And that is the answer that pops off the page when you look at answer choice J. You know that this answer is close to trial number 1. Answer choice F says +4. These are all negative numbers, so that's off in left field. Answer choice G says +2. These are all negative, fairly negative numbers. That's off in left field. And answer choice H is -2, closer. But if you look, we put a -2 here. That just doesn't fall into place. Remember, the information they gave us was -3, -3, -1, and so you see that we would have a -1 as well. We would go 1 more than a -5, 1 less than -5. It would be indeed the closest. -4, answer choice J for problem 32. Take information from here, new information, plug it in, and try and guesstimate your answer based upon what you see. 32 is J. Test 70A, science practice problem number 33. Number 33 states, according to the measurements by a passenger in car X, what trial was car Y moving the fastest with respect to car X? So first thing we want to do here is just get our feet wet. If you look up here at the diagram, we've got car X and Y, which we're dealing with in figure 1. There's a distance between car X and Y. If Y is increasing its speed, then the gap between X and Y is going to be decreased. So we are going to look now in table 1 and look at X and Y. So here we have X versus Y and Y versus X. XY says the velocity of the car X when measured from Y. So if we use this column, that tells us that the velocity of car X when measured from Y, if Y is going faster and increasing its speed and therefore decreasing the distance between car X and Y, then the velocity here, Vxy, will be a negative number. Does that make sense? Come over here and look at table 2. We find Vxy, because Vxy is, when there's a negative number, that means that car Y is catching up to car X. We find the largest number, that would tell you it's going the fastest. The largest negative number, we scroll on down and we see -8 in trial 4. Correct answer, therefore, for this particular problem is indeed for 33, B, trial 4. Test 70A, science practice problem number 34. Number 34 reads, in trial 5, did car X move towards car Z or away from car Z? And did Y move towards car Z or away from car Z? First thing you want to do is get your feet wet, go back up into the diagram and see what's going on here in figure 1. In figure 1, we have car Z here, which is on the highway, and we have car X here, and we have car Y. And car Z is parked. So if car X has a positive velocity, it would be moving away. And if this has a negative velocity, this would be moving towards. That makes sense, because the distance between here and car Y would be decreasing, and the distance between car X and Z would be increasing. So let's go ahead and look at trial 5. When you come in and look at trial 5 is here, and it looks like there is a positive value here in the VZX value. Let's go ahead and see what VZX means. VZX is here, the velocity of car Z when measured from car X. If there's a positive value here, that tells you that the distance is increasing. So that means car X would be moving away. Here you see it's quite simple. Both of these columns here have a positive value, so you know the distance is increasing, and therefore car X will be moving away. Look at your answer choices, and you know that the correct answer has to say car X is moving away. You can go ahead and cross out answer choice G and answer choice J. Now we have to look at car Y. Car Y, we're going to look at Y, Z, and go back up and see what YZ stands for. YZ is here. The velocity of car Y when measured from car Z. Well, remember from the diagram that as you go from
car Y to car Z, it would be increasing its speed if this distance is decreasing. So we're looking for a negative number or a positive number, and what we find here is YZ in trial 5. Here's trial 5. YZ is a negative number, and therefore if it's a negative number, that means the distance between car Z and car Y is decreasing, so it would be moving towards the car. Answer choice F has both of them correct. Car X is moving away because it's increasing its speed, and car Y is moving towards because the distance is getting less. Positive and negative. 34, the correct answer here by a little bit of combination and brain sense, will give you the answer choice F. If you still are a little teeny boggled by this particular question, please see Professor Thomas or one of the Junior Genius tutors to go over this problem in depth. 34, F.
Test 70A, Science, practice problem number 35. Number 35 reads, a .05 sample of powdered seashell was tested in experiment 2. The CaCO3 content was calculated to be 81% based on figure 2, and table 1 delta P for the seashell sample would be what? First thing you want to do here is let's go up to table 1 and look for 81% and see what is close to that. You go on up to table 1. You see in table 1, 81%. Here is the CaCl content right here, and we're looking for 81. The closest thing here is 87, which will give us eggshell, and that is 25.5. So the delta P at 87% is 25. We have 81%, so you know that the delta P for 81% is going to be just a little less than 25. Maybe a guesstimation might be 24. Let's go back down to the answer choices and see what comes out. If you look at the estimation that we came up with was 24. Answer choice A says less than 16. Well, that's not possible because we already know that 87 produces 25% delta P, and we're looking for a guesstimation of roughly 24. 16 to 21 is too small. C says 21 to 26. 24 is right in the middle. Put a dot by it. And D says greater than 26. That can't be possible because, remember, the eggshell was 87% and had a delta P of 25. So 81% new value is going to have a delta P lower than 25.5. So that one can be crossed out right away. D. C is the closest answer. Remember, always try and preview some answer choice. Get a ballpark figure so you know what you're looking for here. 35, the correct answer here is C. Test 70A, Science Practice Problem number 36. Number 36 states, if an additional trial had been done in Experiment 1 in which 0.06 grams of CaCO3 had been tested, delta P would most likely have been what? First things first, let's go up to Experiment 1. We're going to take our new information, which is 0.06, and plug that into Figure 2. Figure 2 is under Experiment 1, 0.06, and predict the new value. Here is Figure 2. We want to find 0.06 right here and go up. Based upon what we see here in the past, you see that we would probably be right about there if that line were to continue out. Then you just simply look across over here and see that the value would be roughly delta P 35. Let's go look for an answer choice that says the same thing. Come on down here and you see 36. 35 is what we predicted. The only answer that's going to work would be answer choice G, between 30 and 40. F less than 30, 35 is between 30 and 40. F is not. H is too large, and J is definitely way too large. Once again, you just look at that chart and see that the only answer that makes sense up here for 0.06, that line is just basically transcending up further, equals 35. So between 30 and 40 has to be the only answer that's going to be working here. This particular problem, the correct answer therefore is going to be answer choice G for 36. Test 70A, Science Practice Problem number 37. Number 37 reads, a student claimed that in Experiment 1, increasing the CaCO3 that was added to the acidic solution increased the reaction rate. Does Figure 1 support this claim? First things first, let's go to Figure 1 and look for the relationship. Remember, as we increase one, what happens to the other? We'll go up to Figure 1, and in Figure 1 you see here we're dealing with time on the x-axis and pressure on the y. We'll take 2 seconds for example and see here as we go from 0.01 grams of CaCO3 all the way up to 0.05 grams at the 2-second mark, you see that as we increase the amount, the pressure increases for the same time. So it is a direct relationship. The more you put in there, the more pressure it's going to produce. So the answer on that is direct relationship, so it would be yes. Anytime we see an answer choice that says no, we can go ahead and cross it out, because no would mean that there was no relationship or an indirect relationship. No for C, that can be crossed out, and no for D, that can be crossed out as well. We're left with A and B. Here's what A says, yes, because the time to reach the maximum pressure was shorter for 0.5 than it was for 0.1. Let's go ahead and spot check and see if that's a true statement. Scroll on up. Take a look again. We looked at 2 seconds. Here, 0.05, and here 0.01. And here we went all the way up at 2 seconds and then just a hair longer and we were at the maximum, whereas here in 0.01 we went up, but it still gradually went up, went up, and it took a while before it got to its maximum.
Here it went up quick when the mass was at 0.05. So that is a true statement. Go back down there and take a look. The shorter time, 0.05 than it was in trial 1. That's true. Let's look at B and see why B is wrong. B says yes, but the time to reach the maximum pressure was longer in 0.05 than it was in trial 0.01. Well, you already saw that because of the curve, you can see that we reach 0.05 pretty fast up here, and then it just basically tails off and goes up a teeny bit more and then levels off, whereas here it goes up, but then it goes up, 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 up to get to its maximum time. Maximum peak for 0.01 takes you about 9 seconds, whereas here with 0.05 its maximum time is right around 3 seconds. You see that? Correct answer therefore for practice problem number 37 is going to be answer choice A.
Test 70A, Science Practice Problem number 38. Number 38 states, which of the following assumptions must be made to properly interpret the results of experiment 2? First thing you want to do is let's get our feet wet and go back up to scientist experiment number 2 and see what they're doing here. Here is scientist 2, experiment 2, and here's what they say. Students use the procedure from experiment 1. So now we have to go over and look at experiment 1. Experiment 1, they used a flask fitted with an airtight cap to measure the pressure, and then they looked at the time. They added CaCO3, and here is what the results they got from figure 1. As you increase the time here, we go from 100 to 135 at the 2-minute mark. You see that basically things are going up here. The more you add, the quicker the reaction, and the lower, it takes a little bit longer to reach its maximum over here, right around 9 seconds, whereas over here around 3. There's a direct relationship between time and pressure all the way up, I would say, to about 9 seconds. Come over here and start looking, seeing what 38 says. It says, which of the following is an assumption made by interpreting the results of experiment 2? F says, in each trial the pressure stopped decreasing by the 14-second mark. Well, you know that that's not true. If you simply look in experiment 1, which is 2 is a continuation of 1, they use the same procedure. 14 seconds, it looks like the relationship here is positive, not negative. Decreasing would suggest that that's a negative relationship that can be crossed out right away. Answer choice G, in each trial the pressure stopped increasing by 14 seconds. If you look at figure 1, what happens at 14? We just basically, we reach our peak here for even the lowest level at 9 seconds, and then basically you're at the maximum here for 01, 02, 03, 04, 05. So they basically just shut the equipment down at 14 seconds. They stopped it. Answer choice G is in the right area of what we're looking for. Let's take a look at H. Each of the substances tested was composed entirely of CaCO3. That's false. Let's go ahead and take a look why. If you look at table 1,
Table 1, you see here, it's a percent mixture. Some of these have as low as 25% cement mixture. So there's other things in there. So that's basically false from Table 1. If you look at the next answer choice, J, it says none of the substances tested contained CaCO3. Once again, Table 1, that is false because the whole experiment is testing CaCO3. From Table 1, you see there's a percentage there. The only answer choice that makes sense to us here is answer choice G. If you're a little weary about experiment 2, go back, read the little intro, and see that 2 is based off of 1, and then look and see what they did in experiment 1. Then look at your answer choice to preview an answer. Start crossing out things you know is wrong. 38, the only answer that's going to work here is answer choice G. Test 70A, Science, Practice Problem, number 39. Number 39 states, which of the following assumptions was made about each substance tested in Experiment 2? So first thing we want to do is go to Experiment 2 and get an overview of what's going on here. First of all, Experiment 2 is right here. And in Experiment 2, it said they used the same procedure as Experiment 1. Now we're going to test different substances. We can find those substances in Table 1. We have antacid going all the way down to eggshell and cement. Okay, now what are we testing? When we come over here, here is Experiment 1. We're going to use the same procedure, but the same procedure, we're going to have to be doing the same thing and looking for the same concepts here. So let's read the mini intro. We're talking about calcium carbonate, its primary component in chalk and eggshells. The CaCO3 reacts with acid to produce a CO2 gas. So we are going to be looking for time versus pressure, and when you produce a large amount of gas, the pressure is going to increase as the gas increases. More gas, more pressure, common sense. So we're now testing to see if a greater amount of CaCO3 will produce a larger amount of gas. You come down over here. What is an underlying assumption, therefore? If you look over here, answer choice A says CaCO3 was the only component of the substance that would not react in the acid solution to produce a gas. That is wrong because the concept of the whole experiment is to see pressure versus time and the amount of CO2, which is gas. So we want to find out that reacts with gas, will not react with gas. So that is opposite of what we're looking for. B says CaCO3 was the only component in the substance that would react with the acid solution to produce the gas. Now that sounds on track. Here, if you look at some of the different things in Experiment 2, in table number 1, you see that we have CaCO3 in antacid, but that's only 34% CaCO3. So if gas is produced because of CO2, which is a gas, then they're assuming that nothing else in antacid A caused the production of CO2 or gas. So this makes total sense here. Answer choice B is the correct answer. It's a basic science concept. Nothing else, hey, we're assuming nothing else is reacting in an acid to produce the gas because we are collecting the gas to see what the delta P value is. Let's go ahead and take a look at C. C says none of the components of the substance would react in the antacid to produce a gas. Well, you know that that's wrong, because the whole concept is we're trying to see if CaCO3 produces CO2 or produces a gas. The whole basis for everything we're doing in this passage is about CO2 gas. So that is wrong right away. Answer choice D says all of the components of the substance would react in the antacid to produce a gas. Well, if that was the case, then we wouldn't be testing anything. Once again, we go back to the center of the whole passage in the mini introductory paragraph. We are looking at CaCO3, and we're looking at what is causing CO2 gas. Gas, CO2. It's a Scooby-Doo off of each other. The underlying assumption in experiment 2 is that nothing else is causing CO2 production, because we only have 34% CaCO3 in antacid, but maybe there's something else in there that would cause the production of CO2. They're assuming that that's not the case, otherwise they would have calculated for that and made some special arrangements by separating that out before they tested it. Once again, the correct answer for 39, it's a little bit of common sense based off of science, is answer choice B. Now listen, if you got this one wrong, don't sweat it. Listen to the instructions in the video. If you still don't quite understand this, please chat with Professor Thomas or one of the Junior Genius tutors about this particular question. Once again, 39, B.
Test 70A, Science, Practice Problem number 40. Number 40 is a long question here. You're going to have to write some things down here. Here's what the question says. Suppose 1 gram of supplement B were mixed with 1 gram of eggshell to form a homogeneous powder X. Then 1 gram of antacid C and 1 gram of cement were mixed to form a homogeneous powder Y. Based on Table 1, if powders X and Y were tested as in experiment 2, which powder would have a higher delta P? The first thing that we want to do here is go into Table 1 and find supplement B. Let's go ahead. We're going to be going up and down here. So let's go into Table 1, find supplement B. Here's Table 1, find supplement B. It's right here. And we see that in supplement B, we see the CaCO3 content is 0, and therefore the delta P is going to be 0. So now we scroll back down and we simply just write this information down. Here's what we wrote. Supplement B equals 0%. Now, we're going to go over here and supplement B is mixed with eggshells. Okay, so let's go up and find eggshells. Same thing. We look in Table 1. We find eggshells, and eggshells is here. And that is 87% CaCO3. So let's go ahead and write that down. You come down over here, we write 87%. Now, powder X contains 0% CaCO3 and 87% CaCO3. That gives us a total for X as being 87%. Let's go ahead, calculate the same thing for Y. Antacid C. We'll scroll on up, find antacid C in Table 1. And antacid C in Table 1 gives you 40% CaCO3. Let's go ahead and write that down. Y equals 40% antacid C, which is CaCO3. Then we're going to add that to cement. We'll go back up to Table 1, find cement. And in Table 1, cement is here at the bottom, and the percent is 25%. Let's go ahead and write that down, and we will get a total for
powder Y. Powder Y is 40% antacid C, which is CaCO3, and it is 25% CaCO3. 40 and 25 gives you a total of 65% versus X, which is 87%. Let's go back up there one more time and look. Higher contents of CaCO3, does that produce higher delta P or lower? We have a total for powder X is 87%. So let's see for percent of 87. That will give us about eggshell. The correct answer here, delta P gives us 25. And then let's find something close to powder Y, which is 65%. And when we come up here, we have 40%, which gives us an 11. So you can see the higher percent of CaCO3 produces a higher delta P. If you look at your numbers here, we write our arrows in. That is a direct relationship. The more higher percent of CaCO3, the higher the delta P will be. We can test this out. 25 gives us 7.3. 31, we go up to 9. 34, we go up to 10. 40, we go up to 11. And 87, we go up to 25. It's a direct relationship here. So you know the correct answer for this particular problem is going to be the magic powder that produces the highest percent. In this case, we see that powder X has 87%, so X will have the higher delta P. Answer choice F says that X and powder X would have a higher CaCO3 and a higher delta P. Make sure there's a lot of information here. Take what you need from here and write down information here from table 1. Write it out so you don't get confused. 40 is F.